Hi there, folks. How's it going? This is Mike coming back at you with a continuation of our previous video on Foundations of Math 2. We began talking about measures of position, specifically percentiles and quartiles and things like that. Now we're going to see how we combine these things in a box plot. Also, perhaps more commonly referred to as a box and whisker plot. So we can visualize the smallest value in our data set, the largest value, and the three other quartiles by drawing a box and whisker plot. How do we draw a box and whisker plot? First thing you have to do is you have to find your quartiles. And the one thing I would even suggest you do before this is to take your data set and put the values in increasing order. So it's easier to find your quartiles. But once you've found your quartiles, and you obviously easily have your smallest and your largest values, you're going to draw a number line that begins before the smallest value and ends after the largest value. And you're going to draw short vertical lines above the number line at the lowest and highest values, just so we can see where this thing is going to start and where this thing will end. After you've done that, you're going to draw a rectangular box over this number line that you make. And for the sides of our box, use slightly longer lines than what you did for the smallest and the largest values. Your rectangular box is going to start at the first quartile, and it's going to end at the third quartile. You're also going to draw a vertical line through the box at the median, or the second quartile. You're going to sort of enclose that box. And then lastly, you're going to draw horizontal lines from the lowest and largest values to the edges of that box. So we're going to do a couple sample problems to see how we do all this fun stuff. So we have a set of data below here. We're going to create a box plot for this data here. So again, let's get these data values in increasing order. This may take a little bit of time, just making sure you don't forget anything here. Our lowest value is 60.6. Then I see a 65.2. Anything less than that? Nope. Okay, now into the 70s. Anything less than a 73.8? Yes, that. Oh, we have something smaller, 71.4. Next largest value was at 72.2. Next largest value, I have a 73.8. Anything just less than a 73.8? Not quite. 76, no. 74.1. 76.0, no. It's a 76.7, so not quite. So 76.0. Now we have that 76.7. And then we have 77.4 and the 79.9. And then we have the 82.8 and the 85.4. So now we have our pieces of data in increasing order. We can clearly see that this is our smallest value, and this here is clearly our largest value. Now we need to find our quartiles. We need the median first, and then from there we can easily find our first and third quartiles. So just first thing we need to look at is how many pieces of data do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have an even number of data points, which means that we're going to have to find some averages to figure out what our quartiles are. So the median for the whole set of data, this is the 6th value, that's our 7th value. If we take the average of these two numbers, then that average is going to be our median. That's going to split our data in half. So if I do 74.1 plus 76, and I divide that by 2, that is going to give me 75.05. So there is my second quartile. Now looking at the data values less than this guy, if I find the median of these values, that median is my first quartile. So again, we have an even number of values. Here we have 6. So I need the middle two values, which are the 3rd and the 4th, and I'm going to find the average of those two things. And a quick calculation will show that the median of, or the average of those two things is going to be 71.8. So 71.8 is going to be my first quartile. And now look at the 6 data values greater than our median. Take the middle two values, average those, and that average is going to be our third quartile. And this one, not as easy to do with mental math. So appealing to our calculators here and doing the calculation, we get 78.65. So we've done, so far, we've done the work before step 1 as well as step 1. We've put the data in increasing order, we've found our largest and smallest values, and we've found our 3 quartiles. Now, we need to draw a number line that begins before our largest value that begins before our smallest value and ends after our largest value. Smallest value is 60.6, so maybe having to start at 60 isn't too bad. And then our largest value is 85.4. So, you know, we could do 86, but just thinking of sort of nice numbers here, 90 isn't all that bad. So I'm going to go 60 there. I'm going to use the entire width of my paper here. 90. And I'm just going to sort of try to break this out into thirds, somewhat nicely here, so that we can have nice markers for the 70 and the 80. And now you sort of have freedom here as to how you want to try to break things out from here. Let's try going by ones. So I'm going to cut each of these pieces in half. Things may not be perfectly to scale here, but we'll still work with it. So we have each of these ticks is just one more than the previous. So there is our number line that begins before the smallest data value and after the largest one. Next up, I need to draw short vertical lines above the number line at the smallest and largest values. So I'm going to try to estimate where approximately 60.6 is. I'm going to say that's about there. Once more, trying to do things by hand and trying to estimate with these decimal values of 60.6. There's a little bit of leeway there. And then my largest value, 85.4. So I'll say about there. It's pretty close to 85 and a half. So that was step 2 that we did. We drew our number line and we plotted the smallest and largest values. Now we're going to draw our rectangular box, and now we're going to plot our quartiles. So I'm going to start with, well, really you can start with whichever quartile you want, because they're all going to be plotted here. First quartile, 71.8. And as I said, go with a longer line than what you did for your smallest and your largest value. So there's approximately 71.8. Here's Q3, which is 78.65. So a little bit over halfway. That is technically slightly over halfway. And then we have our median of 75.05, basically right on top of it. We create a rectangular box with these things here. And what you would typically do, this is my lack of knowing how far up or down these lines would have gone. Typically, you would draw this a little bit higher so it's not running into your real number line. That's a small error on my part. So we drew the rectangular box with our 3 large lines through it. And then lastly, we draw those horizontal lines from the smallest and largest values to the edges of the box. So that going there, this guy going there. And your line should not go inside the box. That's an error on my part. So this is what your box plot or your box and whisker plot would look like. It's not also that uncommon to see the values here being actually written out. So your smallest value, your quartiles, $78.65, and then your largest value here of 85.4. It's not uncommon to see something like that as well. So maybe you see the values listed, perhaps you don't. So that was our first sample problem there. We're going to go on to our second one here. And I'm actually going to challenge you guys. I know you only saw one sample so far, but try to figure this guy out on your own. You know, put the data in increasing order, find your quartiles, draw your real number line, draw the vertical lines as you need to, and then create the box and do all of that stuff. So pause the video here. Try to figure that out on your own. And once you've gotten so far, and or if you think you have it, press play. When we pick back up with the video, we'll have some of the work done, but not all of the work done here. So try this on your own. Once you think you have it, press play, and we'll see if you were correct. Okay, guys. So I have taken our set of data. I've put it in increasing order. I've found the smallest and largest values. I've found the quartiles, and I've set up my real number line here. We had 11 pieces of data, so this makes finding each of our quartiles very, very nice. You should have found that your median or your second quartile is 108, first quartile is 97, and second quartile is, or sorry, third quartile is 123. I had my number line starting at 60 and going to 140. You didn't have to do that. You do have some freedom as far as how you, or as far as where you have your number line start and end, and the spots in between. You know, that's there's some freedom there. But let's plot our smallest and our largest values. Smallest value of 66. Again, I'm just going to kind of estimate that it's about there. 127. This is 125 here, so going a little bit more. Say something like that. My second quartile, my median of 108. Let's go about there or so. Again, this isn't super detailed of a number line, so there's a little bit of room to work with here as far as whether these things are actually spot on or not, but at the very least, they are close. First quartile of 97, going about here or so. Roughly. And then third quartile of 123 will go about there. That'll sort of roughly do what we want. So we're going to create the box. And then draw those horizontal lines to the edges of our box from our smallest and largest values. And again, I will label the smallest and largest values as well as the quartiles. And there we go. So that's roughly what our box and whisker plot should look like. Main thing is that you had your smallest and largest values as well as your quartiles figured out properly. The specific scale that you used for your line down here, you have a little bit of freedom to figure out how you want to showcase that, but just making sure that you have the right values and then making sure that they make sense compared to the scale you have on your number line. Now, what can we use these box plots for? Box plots can help make it easier to find outliers. We were introduced to this word a couple videos back when we talked about the mean, median, mode, and the mid-range. Outliers are values that are significantly different from the sort of core range, if you will, the sort of more grouped together pieces of data. And we have a sort of standard rule and a standard calculation to figure out if you have any outliers in your set of data. The sort of standard rule and calculation for determining outliers is that if you have any value that is less than Q1 minus 1.5 times IQR. IQR is that interquartile range that we talked about at the end of the previous video. So take that IQR, multiply it by 1.5, yeah, and subtract that from your first quartile. If you have any number less than that, then that number is considered to be an outlier. Or if you take that IQR, multiply it by 1.5, and add it onto our third quartile. If you have any number that's greater than that, then that number is also considered to be an outlier. So using this sort of standard rule and this standard calculation, looking at the data set here, do we have anything that would be considered an outlier? Okay, well, first we need our IQR, our interquartile range. If you recall from the previous video, the interquartile range is simply Q3 minus Q1. Q3 was 123. Q1 was 97. So this gives me an interquartile range of 26. Okay, so I need to do Q1 minus 1.5 times the IQR. Again, quartile 1 was 97. Minus 1.5 times 26. If you do 1.5 times 26, you get 39. And if you do 97 minus that 39, excuse me, you're going to come up with 58. Q3 plus 1.5 times the IQR, 123 was my third quartile, plus that 1.5 times 26, which, as we just said, was 39. So 123 plus 39 is equal to 162. So what we have to do is look and see if we have any values less than 58, then those values are considered outliers. Or if we have values in our data set that are greater than 162. If either of these things hold true, then that value is an outlier. But looking at our data set here, we don't have any values greater than 162, and we don't have any values less than 58. So using this rule and this calculation, we don't have any outliers from the previous sample. But if I had reduced this smallest value by even 10, and it was 56, then yes, we would, according to this standard rule and this standard calculation here. If our smallest value was 56, then yes, we would have one. But because we were given our smallest value of 66, it's not really considered that much of an outlier. So guys, this concludes this video on how to create box plots or box and whisker plots. The steps, the method, drawing these things out, as well as how to find outliers. If you have any questions or comments, be sure to reach out to me, guys. Emails, texts, phone calls, rocks thrown through my window, whatever you have to do. Until the next video, take it easy, guys.